Find the value of leave out something else.
of A.
Oh.
All right, so for example, like simple. So find the value of A, which makes these two vectors, which you call it R1 and R2. R1 is 4I plus 3J plus 2K, and R2 is AI plus 2J plus minus 4K. I want to find the value of A that makes these two vectors perpendicular. So what we say that if they are perpendicular, so if they are perpendicular, then R1 dot R2 supposed to equal to 0. So this is going to give me 4 times A is 4A, 3 times 2 is 6, 2 times negative 4 is negative 8, and that is equal to 0. So therefore 4A would be equal to 8 minus 6. So 4A equal 2. So A would be equal to 2 over 4, should be equal to a half. So that is the value of A that would make the dot product equal to, make the two vectors perpendicular. So want to deal with the other consequence of the dot product now is that if we want to find the angle between two vectors, then how do we go about doing that? Well, we utilize the dot product and a bit of the cosine rule. So so let's just if we want to find the angle between two vectors, then the cosine of the angle between the two vectors is going to be equal to R1 dot R2 divided by the length of R1 times the length of R2. So if we have two vectors and want to find the angle that exists between them, then this is the relationship that we would use. For the cosine of the angle between them so the cosine of the angle between the two vectors, we use the dot product divided by the length of the two vectors. So So we want the angle between R1 and R2. So it's the first thing that we have to do, find the dot product. So R1 is 4i plus 2j plus 3k, and R2 is 5i minus j minus k. So R1 dot R2 would be equal to 4 times 5 plus 2 times negative 1 plus 3 times 1. And that's 20, and 323 minus 2, that's 21. So let's write on the length of R1. Pythagoras theorem in 3 dimension. 4 squared plus 2 squared plus 3 squared. That's 16 and 4, 20 and 9, 29. Length of R2 is 5 squared plus negative 1 squared plus 1 squared. That's 25 and 2 is 27. So what we are saying is that if we're using the formula, then cosine theta is equal to R1 dot R2, which is 21, divided by the length of R1, which is square root of 29, the length of R2, which is square root of 27. We take our calculator and we work out that. So that's 21 divided by square root let me use the calculator. Bracket square root of 29 divided by square root of 27, close bracket, equal.
Sir, we get 41.37 degrees.
How much?
41.37 degrees.
All right, so let me just write it like this. Theta is equal to cos inverse of 21 over square root of 29 times square root of 27. 41.37 degrees. All right, so that's the angle between two vectors. So we want to look at now what is the cross product of two vectors. Yeah, go on to that. Everybody all right, or you just watching me work, so problems are there.
Good man, good sir.
All right. So now, so I always find that it's just best to deal with the mechanics first. So let us say R1 again is equal to the same thing as
Look at me down, you know. Oxide board material.
4I plus 2J plus 3K, and R2 is equal to 5I minus J plus K. Oops. All right, we define the cross product as R1 cross R2 as a determinant. I, J, K, and then the next row is made up of R1, which is 4, the components of R1, 2, and 3. And the next row is made up of the coefficients of R2, sorry, not components, coefficients. 5, negative 1, 1. But remember how to find determinant of a 3 by 3?
Yes. I'm finding that too.
Huh?
But one of the component them and find other two. So you cover
Right, so
three.
we strike out the row and the column with the I, and then we find the determinant of the rest. So strike out the row, and then the determinant of the rest is 2, and so when we strike out the row with I, then that leaves 2, 3, negative 1, 1, and then it goes plus, minus, plus, whichever row we pick. We can pick any row or any column to work across, but we are going across I, J, K. So it's plus, then it's minus J, and then we strike out the row and column that J is in. So that's 4, 2, 4, 3, 5, 1. So that's what? 4, 3, 5, 1, and then plus K. And we strike out the row and column for K, and that leaves us with 4, 2, 5, negative 1. So the cross product is defined as the determinant ijk with the components of the two vectors that we have. So that is going to leave us with I times 2 minus 3 minus j 4 minus 15 plus k minus 4 minus 10. Right, multiply the leading diagonal and subtract the subordinate diagonal. So that's 5i plus 11j minus 14k if my maths is correct. So check if my maths is correct. So that's the mechanics of how we find the cross product. But what is it that cross product gives us? Well, what did you say that it gives us?
Parallel vectors.
All right. So if we have two vectors, the cross product is perpendicular to both vectors. So if this is A and this is B, A cross B is a vector perpendicular yeah, so A cross B, we have a vector A and the vector B, and we find A cross B. The A cross B is the vector that is perpendicular to both vectors.
So the red arrow would represent the cross product vector, right?
Right. The red arrow is the cross product vector. So the other definition that we have is A cross B is equal to the length A, length B, sine theta. Yeah, so times n, which is the left out part. All right, so whenever we find the cross product, it is a vector that is perpendicular to vector. All right, so those are some of the that's the information on vectors that we want to pass on. So that's information, but how we find the cross product, how we find the dot product, how we find the angle between the two vectors, etc., etc. All right, so we want to talk about two main things now: the equation of a line and the equation of a plane.
Excuse me, sir. Can I say the first thing you did?
Very first thing.
Yes, sir. I just not too long coming.
Is we up your side?
Sir,
Mm-hmm.
when me join this thing later, I can't write it now because I can't just start write something at the middle now. So what me suggest that if the recordings can be posted so that at least we can go back to the recordings and do some writing. Because me join this thing, me join class late again due to circumstances beyond my control.
Okay. Yes, Sergeant. Somebody recording it, so I don't remember who recorded it, but it is being recorded.
What about last week? Yeah, I was asking for that one from
I still haven't recorded, but I'm told that I'm going to have to post it to YouTube if you are going to see it.
How soon you want to do that, sir?
I'll send the link, sir.
No, it wasn't. It wasn't recorded in the cloud or whatever it is. It was recorded on my computer. So, so that is the problem.
Right,
sir, you can hold on, sir.
so how soon before you send it to
as
YouTube?
soon as I figure out how to send it to YouTube.
Guys, I can assist, sir. Tell him how to send it to YouTube.
Because I just learned today. I am hopeful when it comes to these. It is appalling that I am a lecturer at the University of Technology, and when it comes to technology, certain technology,
You're not gonna know everything, sir. But sir, you tried to do so during the course of this week, right, sir?
Yeah, man. I was trying last week, but I was finding out a few. Because every time I tried something, I realized it don't work. So I was trying something else, and I realized it don't work. Until my son just told me, "Sir, I have to put it on YouTube." So I shall put it on YouTube,
That's cool on, sir.
assuming that it is going to go viral and I'm going to get rich.
Over time, sir. Over time.
Not before the time, sir.
Okay.
Yeah. The more you send student to it and view it, the more.
Yes, wealthy I become.
That's sir. Thing that I see, sir. One of the University of Harvard, or Princeton, one of them University I see and South here.
You see what?
Let me see what I do and say, all right, let me pay out 40,000 US a month to teach their kids.
No.
That's cool on, sir.
I have no desire.
What?
I am racist.
No, man. Them not ask if you do it online, man. They stay right in Jamaica and do your thing.
I'm still racist.
Your racist have no boundary.
No, sir, I have no boundary.
Hey, sir, we don't trust them white man to tell the truth in the sir. Don't trust them at all. They may just kill them and not come out in it.
I live amongst them for 4 years, and what I know about them is that you and them can't have nothing. And them just go and tell the biggest lie by you and we try to make you lose whatever job or whatever it is. And you and them never have nothing. You pass them and say, man, it's not like say you had an argument, you didn't step on nobody toe, you didn't try to take nobody's girlfriend or nothing. There's nothing you can see, and then them just go. Because them live their life threatened, especially by black people. So they spend all of them life threatened.
I don't know what happened to these people. I don't know if they think that they are the only, they are God's creation only.
And well, like I said, I don't know. And
it's a systemic thing, an inbred, inborn kind of nature in them for just hate black people, to just become jealous of black people, to covet what black people have. I don't know what in the world wrong with these people. Well, not all of white people are like that, but I'm telling you don't know how to trust. Police will just kill a white man will just kill you as a police officer and nothing comes out of it.
Yeah. Well, what I know about them is that over the years, you know, as engineers, we build models. So I look at it like, say, suppose them see me like, oh, me see a green lizard. My fear of a green lizard is irrational. And you make up all kind of stories, say, them think they will bite you and kill you, you know, and poison you, you know. And all them type of thing. That when you check it out, the poor green lizard, don't mind it what business and I carry out it to the life.
So you know, all them talk about bullfrog, sir.
Mm.
When we spit pan, you get cocoa bet.
Right, all them things. So me figure say them look from black people same way. So we're coming like one of them. You understand? So I stay to myself.
Dangerous people don't trust me, not trust them a bit. Me there in Jamaica and see what them are going with. And believe me, it is heart-rending. Their intention is always to reduce the black man to a boy or something less than a man. And that agitates the black man.
Mm-hmm.
Nothing is degrading and insulting when somebody tries to reduce less than who you are. And that's how white people are.
Mm-hmm.
So you know, look apprentice, I'm not racist, you know.
Hmm?
I look apprentice, so we can grade like you, sir.
No man, if you live amongst them long enough. I never went there. No, lie. Lie. We did go there. We did go there with some house. But my brethren who tell me, say, me have the house. I say, we must watch show like Amistad and all them show them. Him now. Him tell me when I was going over there. Him live over there still, you know. Him now. Him make me almost feel like exam one time. Because he might talk things now. He get radical. He talk things like, black man must get up first in the exam. Show them this and me like idiot go jump up out the exam and walk out. Say me bright. Nearly fail.
Wow.
Never again. Anyhow, back to reality. Jamaica we live. All right. So suppose we have a line passing through AB. So I'm going to give OA. I'm going to give it that it is a position vector, and then it is let us say it is, I'm going to write it like this, 2, 3, and let us say that we have OB, and OB is 5, 7. All right, so we are giving those two. Find the equation of the line through A, B. So we want to find the equation of a line that passes through AB, and we are given 2 points on the line. Just like when we find the equation of a straight line, you need 2 points on the line. So the two vectors, we have OA and we have OB, and then we need to find the equation of the line. Well, it is slightly to me it is easier than finding the equation of a line. So it's not XYZ, it's XY. Ignore the Z, please. So now, what is XY going to be equal to? Well, because XY, which we call in a point on the line. So let me just remote this it. I'm doing it in 2 dimensions. Let me just correct something in the house here. The teenagers. Hi, excuse me. Hello. All right. There. I have probably about a teenager inside of the house. All right. So we are saying that any point on the line, we call it XY. So we want the general equation for any point on A, B, right? The equation we want it for any point on A, B. So now, so we would need A, B first of all. And we say that AB is A to O, and then O to B. So now AB is going to be AO, which is -2, -3, because we're going to spin this around, plus OB, which is 5, 7. So that is 3, 4. So A to B is 3, 4. So now, how do we get from O? If we are the equation on the line says we're starting from O, and we want to get to a point XY, which is on the line. Well, any point XY. So here's where I want you to follow me now. I'm at XY. And I'm starting at O. So XY would be O to the line A. All right. So if you think about it like this, consider O to be halfway tree, and your wife, husband, baby mother, baby father, girlfriend, whatever, significant other, broke down somewhere on Spanish Town Road. So somewhere on Spanish Town Road, that is the point XY. You're in halfway tree. First of all, you have to get from halfway tree, which is O, to Spanish Town Road. So you go from O to A, plus what you're going to do is travel some distance, lambda, along Spanish Town Road, which is AB. So XY. So now the equation of the line is that XY is equal to OA plus, sorry, let me undo that. We know what OA is. So OA is 2, 3 plus lambda. AB, which is 3, 4. So you get from, what you're saying is that you need to get from O to XY. So you get from halfway tree to Spanish Town Road and somewhere, some distance, lambda along Spanish Town Road. So that is the parameter that we change. All right, to get to any point XY on the so this here would be the equation of the line. All right, so that would represent the equation of the line. So you need position vector of a point on the line. And you need
Sir. Yes, sir. Lambda times AB is the point somewhere on the line.
So lambda times AB would represent some. So you'd get, what we're saying is that what's the XY represent the position vector of a point on the line, anywhere along the line. So how you get from O to that point on the line. All right. So we are saying that you would go from O to A, and then you would go lambda, some distance along the line AB. All right. Okay. So you're going, suppose you're going in the positive direction and your wife was actually over here. Then should I tell you, say, no, go back, so that lambda would be negative. So whatever point on the line, all you have to do is change the parameter for positive to negative, and so forth, to get to any point on the line. So the general equation of the line, you see them write it as R equal A plus lambda B. All right, so the position vector of the equation on the line is R equals A plus lambda B, where A is the position vector of a point on the line and B is the vector along the line and lambda is the parameter that is changed. Just and think of it like Y equals C plus M. Well, this would be XM because the X would be changing, M and C are constants and give you the different values of Y. All right, so it's a similar kind of situation for the vector equation of a line. But I have it as down to
Lambda again.
lambda is a parameter that the parameter that you change to get to any point on the line. So let me write that down. Yeah, so as to avoid confusion, let me change this. Yeah, so going through another set of example now. So find the equation of the line, and it has we have two position vectors on the line. So want to find the equation of the line. Freighter, we had a dispute. Dear Freighter,
Yes, sir.
hey, which part you live? Trinidad or Spanish Town?
Outside Spanish Town.
Oh, they know you can make me a walk around in a quarrel with Mr. Senior at Trinidad you live.
True long. Oh man, you ask me where the freighter them come from until it's down the side of
Oh. I think we tell him say Trinidad you live. So the other day when me accuse you of being stuck in traffic, I tell you say
Yeah, man, because let me leave from town to St. Catherine.
Oh. Mm.
Yeah. I move from town in August, you know.
Oh.
That's why I have so much challenges with the internet because it's a new housing development which them never put in the kind of amenities like internet service.
Mm.
So I have to burn out of data. But I take my time and go on.
Mm. All right. So we can try this question. All right. So I always draw like a diagram. So a two-dimensional diagram will suffice. So we have A, which is 2, 3, 1, if you look at it, and C, which is 4, -3, 2. And we want to find X, Y, Z, any point on that line. So we say that, first of all, so R is equal to A plus lambda B. B is going to be equal to, you're going to find from, this is A, sorry, this is C, and we want to find B, which is the equation from A to C. All right, so let me write it out this way. Let me write it as AC is equal to AO. I want to find from A to C plus OC, which is equal to 2, 3, 1 minus, it's not OA, it's AO, plus 4, -3, 2. So it is going to be 4 minus 2 is 2, minus 6, minus 3 is 6, and minus 1 plus 2 is 1. So what we are going to say now is that R, the equation of the line, is A, which is 2, 3, 1 plus lambda 2, -6, 1. Or if you want to write it out the long way, R is going to be equal to 2I plus 3J plus 2K plus lambda times 2I minus, what just happened there, sir? I'm not sure.
Yeah.
So lambda times 2I minus 6J plus K.
Yes, sir.
Yeah, I didn't hear you.
Isn't it just K for the A?
Yeah. Let me correct that. Just K. So this is my equation for my line. All right, so it makes sense?
You're asking for final one.
Huh?
You're asking for final one.
Usually we leave it like that.
Okay.
All right. So the next thing we want to mention the equation of a
Sir, go a couple of minutes, man. Just a minute.
coming.
Okay.
All right. So now all right. So we want to write down the equation of a plane. So the thing that we have to do is remember that for the equation of the plane, one important thing is that if we have a vector n that is perpendicular to the plane, and our point that we have, any point that we have, x, y, z, any point in the plane, if we have a perpendicular, then we can say that x, y, z times dot, the dot product times n is equal to 0. So that is the principle that we're going to be using. That if we have a vector and we are saying it's x, y, z, dot, and we have a n, so that's the principle that we're going to be using. So if we have a vector n perpendicular, we have to find a vector n perpendicular to the plane. And we are going to say that it is, how do we get to the point x, y, z? Now, the other thing that we are going to be needing is the position vector. Let's call that point P. And then we call that a point so let's just see what let me take a problem and then let us see how we use this principle to come up with the equation of the plane. Or yeah. So example. Just jump off of the deep end. So we're going to find the equation of our plane. And this plane has 3 points in it. So my x, this is my y, my z, and in my plane I have A, I have B, and I have C. I'm given 3 points in the plane. And I'm going to put in another point now. A general point, x, y, z. So I want to be able to calculate any point x, y, z. So how do we proceed?
I'm sorry, Z is a perpendicular height, right?
Z is a
perpendicular height.
Yeah. So
Find a unit vector.
are you here?
Now find a unit vector first.
All right. So we have to find the unit vector first. So let's make a point here now. If I want BA, what is the vector BA going to be equal to? It's going to be equal to BO plus OA. BO is the negative of the point B would represent from O to B. So it will be the negative of 5, 2, 7 plus OA, which is 2, 3, 4. So that is going to be minus 3, 1, minus 3.
I'm going to select B, BO plus OA.
All right. You have to think about it in this way. Remember now, this B here that we have here is how you get from O to B. And this A here, this coordinate system here, tells us how we get from O to A. So if I want to get from B to A, then I have to go from B back to O and then O to A. Right? If I want to get from B to A. Okay, it's because we are only given these routes. O to A, O to B,
I
O
was
to
looking
C.
at the diagram, confused.
Oh. It clearer now to you what we're doing or is still confusing?
Yeah, man, clear now.
All right. Please allow you to, but then proceeding.
Sir, make it clear, man. Clear.
All right. So now we want B to C as well. So B to C. That's going to be B to O plus O to C. So you see minus 5 to 7 plus 2, 3, what am I saying? Plus C, which is 1, 1, 2. So that's going to be negative 4, negative 1, negative 5. Okay. So now we have B to C, we have B to A, and you remember how, because what we said that we need to find is a vector perpendicular
Cross product, sir.
to the plane. So we have to go find the cross product. So the vector perpendicular to the plane so it's going to be I, J, K, negative 3, 1, negative 3, negative 4, negative 1, 5, and we need to find that determinant. So it's going to be, never know, cross out, that's going to be I. Oh. Give me a second here. So that's I, 1, negative 3, negative 1, 5, minus J. Cross out this row and this column.
Chip out my back.
Negative 3, negative 3, negative 4, 5, plus K, negative 3, 1, negative 4, negative 1. So that is equal I times 5 minus 3 minus J times negative 15 minus 12 plus K times 3 minus 4. That's
Plus
2I plus 4
plus 12, negative 15 plus 12.
plus, no man, because when you multiply these two, you get positive 12, and then we have to subtract, so that's why I put the minus.
Okay, yeah.
Yeah, okay. All right, so that's a 27 positive 27 and plus 7k. So we have the first part of the solution. So now,
Sir,
yes,
isn't that
Sir, the
supposed to
5
be a
supposed to
minus
be
5?
negative.
Yeah.
oh, so we have 15. This one here, sir. This one here. True? No, this
Sir,
one
in the
negative.
That's correct.
Oh,
It's
so that's
supposed to
a
be
negative.
negative in the
15,
Supposed to be negative 27.
negative 27, and the one minus. Yeah, correct.
That is correct.
No,
The
the
negative
5,
50 is
the
correct.
5 in
But
the
supposed to be
matrix
negative
supposed to be
27.
negative 5.
The 5 in the
Positive.
matrix.
Supposed
Which
to be
one?
negative 5.
No, man. 5 times negative 3. I'll give a
No.
negative 15.
The 5 in the original matrix is negative.
Oh, okay.
Sir, for
Okay,
B,
yeah,
we
yes,
have
sir. Yes, sir.
negative
Right,
4,
sir.
negative 1,
Right.
negative 5.
Yes, sir.
So
Right,
it's
sir.
supposed to be negative, and it's supposed to be negative.
Right.
Mm.
And then now that give me negative 5,
Positive 15.
positive
Okay.
15.
Yes, you're supposed to end up with
So that's supposed to
3,
give me
3J.
okay. Suppose I tell you something like when these things happen because that means sometimes I feel like I'm talking to myself. So whenever you can spot mistake, that means I'm following. All right. So now, so we find the vector. We find the vector perpendicular to the plane. So the next step is that we say we have a vector x, y, z, and then we have to pick up one position vector, any one. So
Cut number 11 from the
That is interclass number. Oh, Michael, sorry.
so let's pick the point A because it's the first letter in the alphabet. That's the only reason I pick the point A. So the point A is 2, 3, 4. So here's the thing now. Sorry, let's not pick the point A. Let's pick the point B for strategic purposes. So we found the vector because we found BA and BC. So we found that the vector that is perpendicular is minus 8i plus 3j plus 7k. Now this arbitrary vector that we have, which is any point in the line, this B here is, B was 5 to 7. So this is RB 5 to 7. My question is, what is the vector from XYZ to B? How do we find that? Well, the vector from XYZ, remember now, we said that these two must be perpendicular and the dot product will give us 0. So the point is an arbitrary point because we want to find any point in the equation for any point XYZ in the plane. So we pick an arbitrary point, it can be anywhere. We know B is 5 to 7. So what I'm asking now, what is this vector that from XYZ to B? How do we calculate it?
The same cross product.
Oh man, all right, think about it this way. We have is to XYZ.
Sir, so I got add A plus lambda B.
All right, we don't even want the equation of the line. We just want the from XYZ to B. And the to XYZ from O to XYZ is XYZ, and from O to B is 527. So how would we find from XYZ to B?
Also negative XYZ.
Negative
XYZ
plus B.
Yeah.
So how do I make that notation now? So this equation here, let me put it in. Is going to be XYZ minus 5 to 7. So we write it down as X minus 5, Y minus 2, Z minus 7. And then the dot product of that vector with our vector 8, negative 8, 3, 7, that dot product must be equal to 0 since they are perpendicular. So our final step in the equation is to say that the equation is X minus 5, Y minus 2, Z minus 7. Dot the perpendicular now. So we're writing it as a vector. Minus 8, 3, 7. Minus 8, 3, 7 is equal to 0. And so we can work out that to make it look more palatable. Or we can leave it like that. But let's make it look more palatable. So that's going to be minus 8 times X minus 5 plus 3 times Y minus 2 plus 7 times Z minus 7 is equal to 0. So that's minus 8x plus 40 plus 3y minus 6 plus 7z minus 49 equals 0. Or minus 8x plus 3y plus 7z is equal to, carry the 49 over the next side, and 6 is 55 minus 40, that is 15. So that is the equation of the line, of the plane.
Sure, we're not gonna lie, that fly right to what made us all about.
Which part? From where?
From when you start right, the minus X, Y, Z plus B.
Okay. All right. So you follow up to finding the perpendicular.
Correct, sir.
All right. So we are saying now that any point in the plane that we have, all right, so pick an arbitrary point. We just put down a point, X, Y, Z. We know the perpendicular that we found is centered at B. So we are saying now, you have a point X, Y, Z, and then you have a point B. So let me draw another diagram over here. So we were saying that you have the point to x, y, z. Call it x and b. And so we want that line from x to b. We want the equation of that line from x to b. So we were saying that it's going to be b to o plus o, or x to b. So x to o plus o to b. So this point here is what we call it x, y, z. And this point here is what we call it 5, 2, 7. So it's minus this x to o to x is x, y, z. So minus, so x to o is going to be minus x, y, z plus o to b. If I want to get from the point x to b. So this point here is what I'm calling x. So from x to b. So what is the vector for that point? So that's why we say minus x plus b will give us that vector. So this line here from x to b is going to be so we kind of spin it wrong, but it don't matter seriously. But it is going to be, we have x, y, z minus 5, 2, 7. All right, it don't matter if we're going from b to x or x to b. We just want the perpendicular to the line in the plane that's perpendicular to the vector that we have just found. So there, that is how we get x minus 5, y minus 2, z minus 7. I don't know if you follow that part up to there.
Yes, sir.
I still having issues. All right, so from that now, we are saying that the two vectors are perpendicular, so the dot product must be 0. So this, if I write 8i minus 8i plus 3j plus 7k as a vector, then you see, I'm saying that x minus 5, y minus 2, z minus 7, dot minus 8, 3, 7. The dot product of those two things must be equal to 0. So the dot product now is 8 times, minus 8 times the x component, 3 times the y component, 7 times the z component. So that is why you simply write down this next part down here.
Yes, sir. Just a statement them did me. So yes, the dot product for the both of them must equal to 0.
Okay.
Not very perpendicular, the dot product must equal to 0.
Okay. All right, so in general now, yeah, I draw a straight line to save my life. Or anybody else's life. Yeah. So now, let me give you the general formula now. So we have the vector A, B, C, which is perpendicular to the plane. We have the vector, let's call this P. P is, call it X naught, Y naught, Z naught. And then we have a point in the plane. So let's call this P0. Now we have a point in the plane P. P is X, Y, Z. So the equation of the plane is going to be x minus x naught, y minus y naught, z minus z naught. The P naught is a position vector of a point in the plane. So let me write that there. Yeah. P naught, position vector of a point in the plane. P is any point. And so we are saying that the equation of the plane now is x minus x naught, where we have a position vector of a point in the plane, y minus y naught, z minus z naught. Dot product with A, B, C, that's a perpendicular vector, equal 0. So that's the general formula for the equation of the plane. Or as the prefer to write it, ax minus x naught plus b y minus y naught plus c z minus z naught equals 0.
So you can scroll on a little, please. Just a little bit. Yeah, that good, that good. Wait, that's if you tell us internet ship out to us, so I'm gone.
Oh. Well, tell him, say him have to watch the famous YouTube video when it come out.
Boss.
Sir, remember when you post it, sir, you just send the link in our group. Because
right.
it will be difficult to find because you're not popular, so yeah.
Oh, yes. Not world famous, so it will appear in your recommended videos for you to watch. Yet. I'll give it a week.
Pull back up a little, sir.
Which part?
Pull back up. No, no, I guess I don't. Straight to the end account.
Yeah?
That's good.
Them plan for block more road and riot in the US this week again, or them done protest?
I'm not start yet, sir.
Oh, they did that one Saturday now. They did that one Saturday, so they probably go out.
More things are going on, but I'm not at time.
Yeah, them a war. Trump and them a war over vaccine in New York.
Jamaica, them not contest first, man, here. Caribbean and Africa.
Yeah. You see, I was reading Bill Gates' website, and he said that he was explaining the whole of the say phase 1 where you develop the vaccine, the formula. Phase 2 where you test it on a few people, and then phase 3 where you give it to a large number of people, and then you watch them to see what happens. And then if nothing happens, then you can go to WHO and say it worked, and you can start manufacturing it full scale. So I suspect that we are phase 3 because I don't hear them, all of the vaccine, them, they only hear them ready, but when they hear nobody got no WHO. So I suppose we are the large scale trial. Jamaica, South Africa, Brazil, Cayman, Barbados.
Black people.
Then I must test it for black people. Why not test it for white people? The good up people.
Sir, but if well, some people asymptomatic and them barely sure, or are not sure nothing there. So how you go them are gonna get it?
Well, they're going to give you it. And then watch and see if anything happens.
Yeah, but them things I hear before you have if anything happen. I mean that general all over.
Well, it never takes so long for something happen to somebody in South Africa. So
Sir, me not a youth yet, you know. So me no want to come give me and then me go stud up and then calm na youth, you know.
Oh dear. Where is it?
So them have to go try people who have picnic already and say.
But them have to give it to a wide cross section. That is what Mr. Gates said. That's to be given to a wide cross section. So it can't be just given to all people who pass their prime already. You have to give it to some of the young youths who just in them prime. So
you're the time destruction, yeah,
so. But I am not a guinea pig. So nobody that will test it on me and then when them see, if anything. Because what happened with the one with China, the China testing theirs in Brazil, people get sick. England testing theirs in South Africa, people get sick. And now they're going to be tested in Jamaica. And I suspect strongly that people will get sick. So I'm not taking part in no trial. What? Me taking one for the team? No.
Voluntarily.
No, it's all right. So they're going to give me the vaccine and then test and see, check and see if anything happened to me. And then.
Yeah, so if you did I hit the soul up and bus pan, we just know so they don't work. Move on to the next.
Say, oops. And I am. This is documented. Bill Gates who is pushing all of these vaccines is a eugenicist. He has stated more than one time that his primary goal is to reduce the population of Africa by 10 to 15%. That is 100 million to 150 million people that he wants to reduce the population of Africa by. Him says so. No, nobody can say he never says so. That is what him say. Him say Africa can develop unless he reduce the population. I don't know how that works. But anyhow, so he wants to, his goal is to reduce the population by 10 to 15% of Africa. Now, I think it's of black people, because he's also on record of saying that the people who should get the vaccine first are vulnerable population. Blacks, Hispanics, and Native Americans. They should get the vaccine first. It's on record. His wife is on record as saying so. We see the video, me hear when she says so. So,
sir, but,
putting those two things together. Yeah?
Sir, the white people are the most vulnerable, because in terms of population size, they are the minority right now.
They are diminishing. But
yeah.
But nobody not paying that no mind.
Sir, could you scroll up back a little, sir?
And the third thing where is not in dispute is that the last time he carried out, he sponsored a vaccination thing for Kenya. The Catholic priests in Kenya were suspicious. So they get the vaccine that not him was giving out, but him sponsored the manufacturer of. And they found that it was laced with sterilization drugs. They had sterilization chemicals in the same vaccine where they were giving out to people for prevent. I don't remember what it was. Anybody else do that would have gone to jail.
They have a history of doing things, they have a long record of doing something. You know. Long record.
Mm-hmm.
Yeah, some people back in Ethiopia see me room and them Depo-Provera and them something.
Right.
Thing, man.
So I don't trust him as far as I can trade. And so, like I said, I'm not going to be the guinea pig. Because next thing you hear them say, oops, yeah, well, it never really worked, you know.
Take lecture.
And this one here is called mRNA. This vaccine is a new vaccine. It's mRNA, which is a digital vaccine according to them. And what it does is alter your DNA. Now, anything that alters my DNA means that I am a new person.
Yeah, man, and them can shock your DNA growth and the change and everything same way, you know.
Then we have to do that. So I don't know. All of these things, and nobody that answering those questions. Anyhow, let me say, only thing we know is maths. All right, we want to write down some definitions for the Dell operator. Oops. Sure. All right. So the Dell operator is a triangle. And what does it mean? So what it means is take the partial derivative with respect to x.
So for the back and forth, sir, the circumstances being considered.
We did here. Plus take the partial derivative with respect to y of the j component and take the partial derivative with respect to z of the k component. So we have three versions. We have the gradient, which they call grad. So grad f. Let me define f. First of all. So f, we just put it here, is f1 I plus f2, the other component j, plus f3 k. So the gradient f now is partial f partial x I plus partial derivative of partial y j plus partial derivative of f with z. with K. So, and then the divergence you see them say grad V, grad F, and div F. So now the divergence is the del operator, dot product with F. So what it is, that is the dot product of F1I plus F2J plus F3K. Now when you work out that, that's going to give you, remember the dot product is taking each component and adding it. So it's going to give you, you're just taking the partial derivative of the first component plus the partial derivative of the second component plus the partial derivative of the third component. So one, you differentiate the whole function. When you find the gradient, you differentiate the whole function. When you find the divergence or div f, then you're going to differentiate the first component, differentiate the second component, and differentiate the third component with respect to k. And the final one that we, well, it's two more. Curl is a cross product with f. So we're just going to leave it at I, J, K, partial derivative respect to z of f1, f2, f3. And the other one that you might see, all of these things you're going to see in electromagnetics class is all the place you're going to see them.
Sure, and it's supposed to be J squared and K squared. Huh?
No. And the last one.
So the J cancel each other? And the K and
no man. You mean when you take in the dot product?
Yeah.
No, we're not when we take in the dot product. It's not a matter say the i's cancel each other and the j's and I is I squared. I is really one in the x direction. So one in the, if you get technical about the definition, if you were really, like I said, I would be one in the x direction, J is one in the y direction, and Z is one in the z direction. K is one in the z direction. So I times I give me I squared, which is still I, which is 1. If you understand what I'm saying. But if I take the dot product with I times J, some teachers tell you say the two perpendicular, so the dot product are two perpendicular is 0. So it's only when you have I and I that you get back the original vector. But when you have I with J and I with K, since they're perpendicular to each other, they equal to 0. They're not I squared, because I squared will just come back to I. And not complex numbers we're talking about now. We're talking about the perpendicular vectors.
Sorry, can I scroll to the top there? Thank you.
All right, let me just write down the last one. That you might see. I doubt it, but I'm just writing it down. So when you are to find you notice that the triangle is inverted. All right, so you will see curl and divergence and
Oh wait, I'm me gone or everybody got still there. Let me back foot this again, Father God.
Probably got kicked from the meeting.
Good morning, you and gone.
Like a sir gone.
Oh, everybody. Oh, because I wonder if I'm gone again.
I've been gone now too long ago. Well, not